This video is brought to you by Academy of Higher Learning. Hello and welcome. In this video I'll be just going over quotient rule examples. So on the agenda is just quotient rules, examples, sorry. And here's a recap of the quotient rule. If we have a function such as r of x equals p of x over q of x, the rule suggests that the derivative would be the derivative of the top times times the bottom minus the derivative of the bottom times top all over the bottom square. Okay, so let's start with example number 1. It's f of x equals x times 3x plus 5 all over 1 minus x squared. You can use the quotient rule and use the product rule for the top, but a more efficient way would be just expand the top, so it'll be 3x squared plus 5x all over 1 minus x squared. So that's f of x. And then take the derivative. So the derivative would then be much simpler and faster. So the derivative would be the top, so that'll be 6x plus 5 times the bottom function, 1 minus x squared, minus the derivative of the bottom function, so that's just minus 2x, times the top function, so that's 3x squared plus 5x all over 1 minus x squared, and then you just square it again on the entire function. So now just expand, I'm just going to expand it, so that will be 6x minus 6x cubed plus 5 minus 5x squared. And this side will be plus 6x cubed plus 10x squared. Plus 10x squared all over 1 minus x squared squared. Now just collect like terms. Oh, sorry, this is 6x cubed. So just collect like terms and these two will cancel out. And you'll just be left with 5x squared plus 6x minus plus 5, sorry, all over 1 minus x squared squared. So that's derivative, simplified. Now for the second example, it says determine f prime at 4 given the function f of x 1 x plus 1 times x plus 2 all over x minus 1 x minus 2. Now once again you can use the quotient rule and the product rule, but it's once again better to expand it than sub the value in, and then take the derivative and then sub the value in. So I'm just going to expand it first, so it'll be x squared plus 3x plus 2, and at the bottom will be x squared minus 3x plus 2 again. And then I'm going to take the derivative of this, 5x, just going to change the colors, orange. F prime of x would be 2x plus 3 times the bottom, so x squared minus 3x plus 2 times the derivative of the bottom, so that would be minus 2x minus 3 times the dot function, so that's running out of space, x squared plus 3x plus 2 all over the bottom function squared, so x squared minus 3x plus 2 squared. Now all we have to do is sub the value in, f prime at 4, and we should get 11 times, this is 6, this part will be minus 5 times this part will be 30 all over 6 squared. So that will be 66 minus 150 all over 36, and that should give us, if we simplify it, minus 7 over 3, which is equivalent to minus 2.333. So that's the answer. So the last example was basically show that there is no tangent to f of x equals 5x plus 2 all over x plus 2. So basically that have a negative slope. So we have to prove that the derivative of this function is always positive. And again, so basically what we have to do is find the derivative, and then we just have to find the intervals of that derivative. And if the intervals are always positive, like it's always positive, that means it's always positive. And we just proven that there are no tangents that have a negative slope. So let's start with defining the derivative. So the f prime of x would be derivative of the top, so it's 5 times the bottom function minus the bottom function, so that's just 1 times 5x plus 2, the top function, all over x plus 2 squared. Now just expand it and collect like terms, so that will be 5x plus 10 minus 5x plus 2, all over, oh sorry, this is minus 2, because if you expand it, it will be minus 2. X plus 2 squared. And next we just have to, the 5x will cancel out, and this will give you 8 over x plus 2 squared. And as you can see that if you equate it to 0, this uh, the derivative function will always be positive, because the bottom is always going to be positive since it's being squared, and the top is just 8. So therefore the derivative function f prime of x is always positive, and thus no negative slopes. So that